Hi, so in this video we will be learning about the 3 address code. So 3 address code is a intermediate representation which is used in the compilation process. So in 3 address code, the given expression is been broken down into several separate instructions, and these instructions can easily be translated into the assembly language. In simple, you can say that each 3 address code instruction can have at most 3 operands. It can be less than 3 but not more than 3. So we'll see an example. So here it is given that the expression is w equal to x plus y into z. Okay, so this is the expression, and we want to convert this expression into the 3 address code. So first of all, we will make a temporary variable t1, and we will be assigning the value of y into z to the t1. Okay, that is the result of y into z will be stored in the t1 variable. T1 is a temporary variable. Okay, so in the next step we will make another temporary variable t2, and the result of x plus t1 will be stored in the t2. Okay, so in the final step, w will be equal to t1 plus t2, and this is the corresponding 3 address code. Okay. So here you can see that the expression is broken down into several separate instructions. Okay, that is the 3 address code where we have at most 3 addresses. Now we will move on to the addresses and instructions. 3 address code is built from two concepts, that is addresses and the instructions. So the address can be a name, constant, or a compiler generated temporary. And the common 3 address instruction forms are assignment instructions, copy instructions, conditional jump, unconditional jump, and the procedure call. So here you can see a list of common 3 address instructions forms which I said earlier. Assignment instructions are of the form x is equal to y op. Op stands for operator. Okay, operator z. So here x, y and z represents the operands, and op stands for the operator. And the assignments of the form x is equal to operator y. Here the op is a unary operation. The essential unary operations include unary minus, a logical negation, and conversion operators. That is, for example, the conversion of an integer to a floating point number. And next we'll see the copy instructions. So copy instructions are of the form x equal to y, where x is assigned the value of y. Then the unconditional jump, that is if x relope, that is relational operator. Okay, relational operator y go to z. So here the small letter x and y are the operands, and the capital X is the tag, or you can say it's a label of the target statement, and relope is the relational operator. Okay, so if the condition x relational operator y gets satisfied, then the control is sent directly to the location specified by the label x. So all the statements in between are skipped. But suppose if the condition fails, then the control is not sent to the location specified by the label x, and the next statement appearing in the usual sequence is executed. Okay. So this is something very similar to the if else statement, that is, if the condition is satisfied, then we'll be executing that block, else we will be executing the else block. Next is the unconditional jump. So the unconditional jump can be of the form go to x. Okay, here x is the tag or label of the target statement. So on executing the statement, the control is sent directly to the location specified by the x, and all the statement in between are skipped. So here there is no conditions, but instead if we see the go to x statement, then the execution will directly move on to the location of the x specified by the label x, and the all other statements that comes in between are skipped. And the final is procedure call. It is of the form parameter x call p return y. So here the p is a function which takes the x as a parameter and returns y. Okay. In the instructions, we also have something called indexed copy instructions and also the address and pointer assignments. Now we will move on to the implementation side of the 3 address code. So in 3 address code, there are mainly 3 representations like quadruple, triples and indirect triples. So the first one is quadruple. So the quadruple, or you can say just quad, has 4 fields. As the name suggests, it has 4 fields which we call as the operator, argument 1, argument 2 and the result. Okay, so the operator field contains an internal code for the operator. So here you can see the quadruple of the given corresponding 3 address code given here. So in symbol, what we do here is that we will be building a table with operator, argument 1, argument 2 and the result. Okay, then we will be storing each of the variable from 3 address code to this table. Okay, so now look at this 3 address code here. The first instruction, that is T1 equal to minus C. So here the T1 is the result, minus will be the operator. So minus here is the unary operator and C is the argument. So in this instruction we have only one argument. Okay, and coming to the next instruction, that is T2 equal to B into T1. So T2 will be the result, B will be the argument 1 and the star represents the operator, multiply operator, and T1 will be the argument 2. Okay, so similarly the third instruction here, T3 will be the result, minus will be the operator, C will be the argument 1. So this is the representation of quadruple, and the main advantage of quadruple is that it is easy to rearrange code for global optimization, and one can quickly assess the value of temporary variables using this symbol table. Okay, so coming to the disadvantage side of the quadruple is that it contains lot of temporaries, and the temporary variable creation increases the time and the space complexity. Okay, so now we will move on to the triples. So a triple has only 3 fields, which is we call as the operator, argument 1 and the argument 2. So here you can see the triple format for the representation A plus A into B minus C plus B minus C into D. So here you can see the syntax tree as well as the triple format for the given expression. This is similar to the quadruple, but here you have only 3 field. In the quadruple you have 4 field. So here the result field will not be there. Next is the indirect triples. So indirect triples consist of a listing of pointers to triples rather than listing of triples themselves. So in the triples we have a few disadvantages. The first one is temporaries are implicit and difficult to rearrange the code. And secondly, it is difficult to optimize because the optimization involves moving of the intermediate code. So when a triple is moved, any other triple referring it must also be updated. So with the help of a pointer, one can directly access the symbol table entry. So here you can see the indirect triple representation of the 3 address code. So that's all about the 3 address code. We have discussed what is 3 address code, example of it, and the addresses and instructions, and also the various types or various representation of the 3 address code. So thank you.